Okay, in this video we're going to talk about domain and range for the functions that we defined in the last video. And this is going to help us out in the next section when we go to graph these. So let's start off with cosine. Doesn't really matter which one we start with between sine and cosine. They're very similar. So we've got cosine of s. All right, remember that our points are cosine s, sine s, cosine sine. And we want to know what the domain of this function is. Rather than thinking in terms of x and y as we did before, as we did before, like in college algebra and other classes, think of this in terms of input and output. It's a little bit easier when you start getting into other variables like s and theta and r and things like that. So domain is the input. What are the input values? So right here is my input. What are the s values that I can put into this? So missing my angles here. The values that we're putting in are the s values or the theta values that we talked about before. We're putting in all of these angle values or arc length values. Remember, they're the same on the unit circle. So we could put in 0. We could put in pi over 2, pi, 3 pi over 2, 2 pi, and all the values in between. So it's not just 0 and pi over 2. It's everything from 0 to pi over 2 to pi to 3 pi over 2. Then we hit 2 pi and we can keep going, right? So we could have 3 pi, 4 pi, 5 pi, and so on. So it goes on forever. And we can do the same in the opposite direction. So we can go negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. We can go forever in the negative direction. So we can put anything in for arc length. Anything from 0 up and from 0 down. So s can be any value. And that means that the domain is, whoops, not domain, domain is all reals. Okay, so we say all reals, or we say negative infinity to infinity. All right, so we can put anything into cosine. Any value can go into cosine. Now, so that's the domain. Now, what about the range? The range are your output values, the output values. So when we put all of these values, all of these reals into cosine, what do the values that we get out look like? So now we're going to be looking at, when we put in these values, what we get out are the cosine values. So I'm looking at the first set of values as we move around the circle. All right, so we have 1, 0, negative 1, 0, back to 1 again. And then we also have all of the numbers in between. So if I am at any point on here, my x value has to be less than 1. Okay, at no point does this go to the other side of 1. It would have to like bow out and then back again. So no matter where I am, I'm never more than 1 that way or 1 that way, and this would be 0. Okay, so we go from 1 to 0 to negative 1 to 0 back to 1 again, and I never go outside of those numbers. So our output values are everything between 1 and negative 1. So that is our range. Our range is that cosine is always going to be between 1 and negative 1. And so we would say that our range is negative 1 to 1 with square brackets because we actually touch those points, so they're included. Okay, so the domain is all reals. We can put anything into cosine, and the range, the values that we get out again, have to be between negative 1 and 1. We can't get bigger values than that out of cosine. Okay, if that makes sense, then sine should move along pretty quickly because it's pretty much the same idea. So what values can I put in for sine? Again, we're looking at the red values as we move around the circle. Let me just erase these for clarity. We're looking at the red numbers as we go around the circle. So again, we can go around in the positive direction, and we can keep going and going and going forever. We can move around in the negative direction, and we can keep going forever and ever and ever. And so as we're looking at sine, s can be any value. And so the domain for sine is also all reals. Okay, really the same idea as cosine. We can put in any of these angle values or arc length values. as we move around the circle. All right, and then the range is pretty similar too. We are looking at, now we're looking at the second value. So we're looking at 0 to 1 to 0 to -1. And again, we can't move outside of those numbers. So the biggest that we're going to get is +1. The smallest that we're going to get is -1. Okay, we never get higher or lower than that. So that is going to be our range, is that sign has got to be between -1 and 1. So our range is the interval, -1 to 1. Okay, so we've got our domain and range. If you understand one, the other one is the same. Domain is all reals. Range is -1 to 1. Okay, so let's take this idea and move into the other functions that we talked about. So we're going to look at the tangent and the reciprocal functions for domain. We're going to come back to range when we do the graphs. I think in a couple weeks we get to the graphs of these. So tangent is going to be equal to sine over cosine. We talked about that in the last video. And if we want to know the domain for tangent, we can look at the domain for sine and cosine. So the domain for sine is all reals. We can put anything in there. The domain for cosine is all reals. We can put anything in there. But the domain for tangent altogether, we can't put anything in because we have to worry about zeros in the denominator. So because it's a fraction, we cannot have cosine s equal to 0. Okay, or in other words, cosine s cannot be equal to 0. Those would be equivalent statements. So we can put anything in for s except for where cosine is going to be equal to 0. Now there are a lot of places where cosine can be equal to 0 because we're looking at two places here on the unit circle. And then remember, anytime we hit multiples of those, remember all of our coterminal angles? Anytime we hit multiples of those, cosine is also going to be 0. So for example, where is cosine equal to 0? So cosine is equal to 0 when s is pi over 2. Okay, that's right here. Cosine is equal to 0. And then again when s is 3 pi over 2. But then it hits it again when you go around again. So you would add 2 pi to this. What would that be? 5 pi over 2. And then again over here at 7 pi over 2. And so on. We could keep adding 2 pi to these. And then we could also subtract 2 pi from them because we would have all of the other ones. So we could have, how to write this out in general. I'm trying to remember how they have you write these in the homework. Okay, so let's come to the side a little bit and talk about writing out multiples. A little brief math lesson separate from the trig lesson. Okay, if you're trying to write out, we talked about last time, like if you're writing out multiples of coterminal angles, it's like 2 pi n, 30, 60 n. You use that n as multiples. So for example, if you've got like 2, 4, 6, 8, 10, what is that? That's multiples of 2. You could write that as 2n. Okay, if you have odd multiples, or I'm sorry, odd numbers. They're not multiples of anything, but they're the 2n multiples plus or minus 1, depending on how you want to write it. If you start this from 0, then they're plus 1. So I could write this as 2n plus 1. Okay, so this is pretty standard right here. This is pretty standard for how we write in general an even number and an odd number. So even numbers are 2n, odd numbers are 2n plus 1. Okay, so this is even and this is odd. If you haven't seen that before, that's a standard, kind of a standard thing in math. So over here, we're looking at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So if you look, these are all pi over 2. but the coefficient on top is 1, 3, 5, 7. That's the part that's changing every time. So I'm going up by odd numbers, and then the pi over 2 stays the same every time. So I could write this as our odd number, 2n plus 1, times pi over 2. Sorry, I'm looking at my notes. My notes are actually wrong. I left off the pi over 2, but this is right. Okay. I was just making sure my notes are wrong. I was trying to make sure I'd written this right. Okay, so we've got odd multiples of pi over 2. Okay, so you just kind of have to look at that pattern, but I'm giving this to you, so now you know the values for cosine. So now we can come up here. We know that we can't have cosine equal to 0. So this is defined, tangent is defined. There we go. The domain of tangent is defined as long as s is not equal to 2n plus 1 times pi over 2. So odd multiples of pi over 2. All right, that's how we would write that in general. So I can't remember the exact formatting for the homework in the for this section, but we'll come back to that as well. If you have any questions on the homework, just ask me in office hours or send me a text. But we'll come back to this as well when we go to graph. Okay, so everything is okay except for 2n plus 1 times pi over 2, any odd multiple of pi over 2. All right, so if that makes sense, let's see if we can squeeze. Well, I'll tell you what, we'll do one of the other ones, and because I'm going to run out of time on this video. We'll do one of the other ones and see if you guys can figure out the other ones on your own. So let's say we want to do cosecant. Yeah, let's do cosecant. Because secant is going to be similar to this one because it's got cosine in the denominator. So let's look at cosecant, and then I think you could probably do the other ones from this. So cosecant, we have to have sine s not equal to 0. So the denominator cannot equal to 0. We can put anything in for s, but we can't have this come out to be 0 because then we'd have 1 over 0, and that's undefined. So we need to figure out where sine s is equal to 0. All right, so just like before, we look at the unit circle. This time we're looking for where sine is equal to 0. So that's going to be here and here. So at 0, pi, 2 pi, and so on. So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. Okay, so see if you can notice the pattern here. I've got pi in every single one. And my numbers are going up by 1, 0, 1, 2, 3, 4, 5, and then of course they would go negative as well. So they're going up by 1 every time, so that is my n. Okay, n is 1, n is 2, and n in general goes up and down by 1. So this is going to be equal to n pi. Okay, if it had been 0, 2 pi, 4 pi, 6 pi, then it would be our even numbers times pi. So just kind of remember that like these are your basic ones, and you should be able to get the rest from there. So our domain for this one is going to be s not equal to n pi. All right, and then let's put it up. My videos are limited to 15 minutes, and I try to keep them under that. I would try to keep them under that anyway. So I've got 1 minute. Let's see if we can squeeze it in. So secant is 1 over cosine. That's going to be the same as tangent because you've got cosine on the bottom. And cosecant, no, we did cosecant. Cotangent is going to be cosine over sine. And that's going to be the same as this one, okay? Because remember, you're looking at what's in the bottom. So for this one, cosine is going to be like tangent, and for this one, sine is going to be like cosecant. So you should be able to figure those out. It's going to be the same as these two. Okay, so that's the basis for domain, and we're going to talk about range when we get to those graphs.